Okay, we're going to start talking about parabolas. So you should have your parabola information sheet in front of you, and we're going to start first talking about a parabola that opens right. So let me draw a right one. So that would be right or left. Okay, if a parabola opens right or left, it really doesn't matter. The vertex is HK, just like a circle. So this vertex happens at H comma K. And then there's this thing called the Axis of Symmetry, and that is what splits the parabola right down the middle. It would like fold the parabola onto itself. We talked about this before. And because in this case it's going horizontally, the equation of the line would be y equals k. So it could be y equals 2, it could be y equals 3, it could be y equals -7. I don't know, but it's because it goes straight across. It's a horizontal line, so it's a y equals line. The focus is always a point on the inside of the parabola. On the inside of the parabola. Now, the focus is p units away from the vertex. So if you look at the equation, the standard form of an equation, if you look at it, p shows up next to the 4. So this idea of p, that's how many units away the focus on the inside is from the vertex on the parabola. So the focus can be found by taking the h of the vertex, adding p, but k stays the same. So you're adding p because you're going further into the parabola, and if it's one that opens to the left, you would still be adding p, but it would be like adding a negative, so you would then be subtracting. The directrix, there is this line that runs behind the parabola here. That's called the directrix. And that line is also p units away from the vertex. So you've got the vertex. If you go p units right, let's say, you get to the focus. If you go p units left, you go to the directrix. Now, if it opens left, if you go left p units, you get to the focus. If you go right p units, you get to the directrix. So that part's a little confusing, but it's much easier if you just look at a picture of it. So the directrix is, if it opens right and left, it's a vertical line, so it's going to be x equals, and you're going to take the h value and you're going to subtract p, because you're going p under the parabola. So you're either p to the left or p to the right, depending on how it opens. The direction of opening comes from the p value itself. If p is positive, sorry about that. If p is positive, it's going to open right. If p is negative, it's going to open left. And there's this other thing, and it's called the Latus Rectum. I know that's funny, but the Latus Rectum goes through the focus. So you're going to see that in blue. So it goes through the focus and connects one point on one side of the parabola to a point on the other. So go through the focus, connecting one point on one side to another point on the other side. And the whole length of that latus rectum is 4p. That's the length. And it goes through the focus. Okay? So the whole length is 4p. I guess I should say the absolute value of 4p. So that means that, let's say 4p was 12. Okay, this whole length would be 12, but because of the symmetry of a parabola, you would have 6 of it on this side and 6 of it on that side. So that's how you would kind of like gauge those points. The p-value, an actual definition, I'll talk about this when I see you guys again, but the p-value is the distance from the focus to, my thing just died, to the vertex. But it's not only from the focus to the vertex, it's also the distance from the vertex to the directrix. So this p-value, right? You have a vertex. If you go p up from it or p right from it, you get the focus. If you go p down or p left, you get to the directrix. So the p-value is described as the distance from the focus to the vertex, and also it's the distance from the vertex to the directrix. And then the eccentricity, a parabola always will have an eccentricity of 1, and I will describe that a little bit more to you guys when I see you, but just take my word for it for right now. It is 1. And then if we talk about up and down, so let me erase what I have here. I'm going to erase the right and left and explain up and down. So if I draw a parabola that opens up, it would look like this. If it opens down, it would look like this. That one's much bigger. And the vertex is still h, k, but this time, so here's our vertex, boom, boom. This time, the axis of symmetry is a vertical line, so it's going to be x equals h. H is coming from the vertex, the h in the vertex. Over here in the right and left, the k is coming from the k in the vertex. So now, this focus, it's going to be on the inside, so it's either going to be above the vertex, or it might happen below the vertex like that. So this time you're going to be keeping the h, and the k is what is either going to be getting increased or decreased by the p. It's much easier to draw this out, I assure you. The directrix is going to run under or above like that. So this would be y equals k minus p. You're either going to be going down p units, or you're going to be going up p units, depending on how it opens. And the direction of opening, if p is positive, it's going to open up. If p is negative, it's going to open down. So once again, this concept of this p-value is here, that distance is p units away, this distance is p units away, this distance would be p units away, this distance would also be p units away. And you still have your latus rectum, so this distance right here is 4p, so you've got 2p on this side of it, 2p on this side of it. This distance here is 4p, so that's the same.